In this short video, we are going to finish off chapter 5.3 or section 5.3. And from the previous example, we saw that even though we saw that r prime is continuous on the point um, on the origin here, we noted that the curve parameterized by r does not have a tangent line uh, at that point, which means that the curve is not smooth at r at 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 the origin. Now we're going to look at a different question, which is example 5.3.10, where even though r prime of a is equal to 0, we see that the curve parameterized by r has a tangent line at r of a. So it can happen, it might not happen, that we have a tangent line at r of a when r prime of a is equal to the 0 vector. So we are going to look at this particular example. So consider the function r of t, which is t cubed t to the 9, where t is a real number, and let c be the curve parameterized by r. In particular, we will see that if we calculate r prime of 0, it is going to be the 0 vector. However, the curve parameterized by r has a tangent line at r of 0, which is equal to the 0 vector. And this is because this curve c has another parameterization, which here we call v of t, which is equal to t cubed, where t is a real number. So if we look at v of 0, we will see that it's equal to 0 and r of 0 is equal to 0, and v prime of 0 is equal to 1 0, which is not equal to the 0 vector, right? And so therefore we know that if v prime of 0 is not equal to the 0 vector, uh, the vector 1 0 is a tangent vector to the curve parameterized by v of t. But that also means then that 1 0 is a tangent vector to c at r of 0, which is equal to 0, even though r prime of 0 is equal to the 0 vector. So we use the fact that because this curve can be parameterized by two different sets of parameterizations, we use the fact that v of t gives us a non-zero vector here to conclude that the vector, the curve has a tangent vector at the point that we are looking at. So uh, therefore we have this, so that becomes the tangent vector at 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 the point 0 0 there. So here we basically, what we exploited was the fact that this function, oh sorry, this curve c has two different parameterizations, and one of them gives us a non-zero derivative at 0. So that tells us that that value that we get, which is non-zero, is a tangent vector to the curve c. Yes, okay, all right. So that is all for 5.3. Thank you.